Welcome everyone in lecture number 8 of Laplace Transform. In this video lecture, we will learn how to find the Laplace transform of the function of the type t and ft. Means the function which is multiplied by positive integral powers of t. Means you may be asked to find the Laplace transform of say t sine t, right? Or t cos t, or t square sine t, or t square cos t, or t cube e to the power t, like this. I'm writing for you t sine t, t cos t, t cos t, or say t square e to the power t, or t cube sine t, and so on. Means the second function is normal function and the function is multiplied by powers, different powers of t. So in that case, how to find the Laplace transform of such function? So today we are going to learn a new type of rule to find the Laplace transform of such function. So let me define the procedure or the rule to find Laplace transform of such kind of functions. So if say ft is a function of class A and if its Laplace transform is say fp, it is a function of p, then if we multiply this function by t, that is the function become now tft, then Laplace transform of such function is nothing but d over dp of Laplace transform of ft. In other words, you can also write it as d over dp of fp or nothing but f dash p. Very simple expression, last one. So the value of this function is the value of Laplace transform is minus f dash p, means first derivative of function fp with respect to p with negative sign. और आप इसको ऐसे भी समझ सकते हो कि when L go inside this bracket, t will convert it into the derivative with negative sign and L will apply on ft and this derivative will apply on this whole expression. So this is the impact of t, means t converted into negative sign of t over dp when L goes inside the bracket. Okay, this is the effect of t. Now what is the effect of t square? Can you guess? Yes, you are thinking correctly. Let me write it. So in general, if ft is a function of class A, suppose, we have to write it to be sure that its Laplace transform will exist. And Laplace transform of this function is fp, then Laplace transform of t and ft. I am writing for nth power of t, so it will be minus 1 raised to the power n, nth derivative with respect to p of the function fp, where n could be 1, 2, 3, and so on. So this Tn converted into this, and L goes inside this bracket, and L converts Ft into Fp, and this Tn converted into this expression. If we have second power of t here, then we have to differentiate Fp 2 times, and here we have minus 1 raised to the power 2. Okay, so it is obvious that when t has odd powers, you will have negative sign, and when t has even powers, we will have positive sign here. So as the powers of t increases, uh, this becomes quite complicated, because if fp is complicated, then to differentiate it again and again becomes very tedious work. So let us do one example to understand the procedure. Evaluate Laplace transform of t into 3 sine 2t minus 2 cos 2t. Okay, so if you hide this, it is very simple to find the Laplace transform of this expression. But because of this, we have to use the rule that we have understood. So let's do the solution. So let me first use the linearity property. So that we can write this as uh, Laplace transform of t 3 sine 2t minus 2 cos 2t. It can be written as Laplace transform of t 3 sine 2t minus t 2 cos 2t. This gives us two expressions. We mark this as 1 and mark this as 2. And let us solve them separately. So let us first take 1. 1 is equal to Laplace transform of t into 3 sine 2t. So this is equal to, with negative sign, d over dp, because we have only t here, and when L goes inside this, we have Laplace transform of 3 sine 2t. Okay, This is equal to minus d over dp. 3 is constant, and Laplace transform of sine 2t will be 2 upon p square plus 4. Okay, so we have to differentiate this expression. 6 upon p square plus 4, हमें इसको differentiate करना है with respect to p. So first is equal to minus d over dp of 6 upon p square plus 4. So this is p square plus 4 whole square with negative sign in the outside the bracket. P square plus 4, and differentiation of 6 is 0. Then it is 2p. So it is minus minus plus 12p whole divided by p square plus 4 whole square. Let me take the second expression. Second is with negative, Laplace transform of t into 2 cos 2t. T into 2 cos 2t. So because of this t, we have minus d over dp, and Laplace transform of 2 cos 2t. So it is minus d over dp 2 into p over p square plus 4. So let me draw a line here. This implies second expression is equal to p square plus 4 whole square, p square plus 4 multiplied by p, सॉरी 2p का डिफरेंशिएशन हमें 2 मिलेगा, minus 2p into 2p with negative sign here, minus 2p square plus 8 minus 4p square, p square plus 4 whole square. So you can mark this as star, this expression, which is 1 minus 2. So star is equal to 1 minus 2, which is equal to 12p upon p square plus 4 whole square, minus, because of this negative sign we have plus here, 2p square plus 8 minus 4p square whole divided by p square plus 4 whole square. So the answer is 12p minus 2p square, ये दोनों को कंबाइन कर दिया, plus 8 whole divided by p square plus 4 whole square. So this is the answer. Second example is find Laplace transform of t square cos of 80. So what we do here is, because of second power of t, this will be equal to minus 1 raised to the power 2 d2 over dp square into Laplace transform of cos of 80. आपको ये याद रखना है कि t square will convert it into this expression and L will go inside the bracket. Okay, so this is equal to d square over dp square of p upon p square plus a square, Laplace transform of cos of 80 ये होता है. तो we first differentiate p upon p square plus a square with respect to p, and then we differentiate this again with respect to p. So this you can try yourself because this is a quite lengthy portion, so I'm skipping this here. You can do it yourself. Let me do the next example. Example number 3. Find Laplace transform of t e to the power minus t sine t. This is quite interesting question because this function, the function, if you take the function as sine t, then the function is multiplied by e to the power minus t as well as t. When the function is multiplied by e to the power minus t, we have first shifting property, right? And when the function is multiplied by t only, we use the rule of uh, t and ft. So here in this question, we have to decide what should be ft. If you take t into sine t as ft, then you will apply here the rule of first shifting property because this whole is getting multiplied by e to the power minus t. Taking this as ft, you apply here first shifting property. But first you have to find the Laplace transform of t sine t by using the rule that I have told you earlier. If you take e to the power minus t into sine t as ft, अगर आप इसे ft लेते हैं तो आपको वो रूल लगाना पड़ेगा इसमें जो मैंने अभी अभी आपको बताया. पहले आपको इसमें रूल लगाना पड़ेगा इनर ब्रैकेट में फर्स्ट शिफ्टिंग प्रॉपर्टी का रूल और आउटर ब्रैकेट में टीएफटी का रूल, और इधर इनर ब्रैकेट में आपको रूल लगाना है टीएनएफटी का और आउटर ब्रैकेट में फर्स्ट शिफ्टिंग प्रॉपर्टी का. दोनों से ही आंसर सेम आएगा. ओके मैं आपको इसमें दोनों तरह से करके दिखाऊंगी इस क्वेश्चन को. So let us first take ft as e to the power minus t sin t. Then Laplace transform of tft would be minus d over dp of Laplace transform of ft, right? So our ft is e to the power minus t sin t. So Laplace transform of tft is equal to minus d over dp of Laplace transform of e to the power minus t sin t. Now here we apply first shifting property. First shifting property, whenever a function is multiplied by e to the power at, then Laplace transform of such function is f of e to the power, let me revise you, Laplace transform of e to the power at ft ft is equal to Laplace transform of ft, and p is replaced by p minus a. Okay, so here Laplace transform of sin t is 1 upon p square plus 1, and p is replaced by p plus 1 because of negative sign here, d over dp of 1 upon p plus 1 whole square plus 1. So we have to differentiate this. इसको आपको डिफरेंशिएट करना है. So Laplace transform of tft is equal to minus d over dp of p plus 1 whole square को हम ओपन कर लेते हैं, उसमें 1 ऐड कर देते हैं, so we'll get p square plus 2 plus 2p. Now we differentiate this with respect to p, so we will get p square plus 2p plus 2 whole square, and 0 here, minus 2p plus 2 here, and negative sign is also here, so we have 2p plus 2, this negative and this negative become positive, p square plus 2p plus 2 whole square. This is the answer. By first method, when we take this as ft. Now we can also take t into sine t as ft. Okay, so let me do the second method. Second method, let ft is taken as t sine t. Okay, then Laplace transform of e to the power minus t ft will be equal to Laplace transform of ft, and t is replaced by p plus 1 in fp. Okay, here we will get fp. P is replaced by p plus 1 in fp. Now since ft is t sine t, so let me do the solution here. Ft is t sine t, so Laplace transform of ft is equal to minus d over dp of 1 upon p square plus 1 Laplace transform of sine t. So this is equal to p square plus 1 whole square, and 0 here minus 2p. So it is 2p upon p square plus 1 whole square. So mark this as 1 and mark this as 2. Substituting the value of uh, L of ft from 2 in 1. Okay. Substituting value of L of ft from 2 in 1. We will get Laplace transform of e to the power minus t ft will be equal to Laplace transform of ft and p is replaced by p plus 1 by first shifting property. Laplace transform of ft is 2p upon p square plus 1 whole square. P square plus 1 whole square. P is replaced by p plus 1. 2p plus 1 p plus 1 whole square plus 1 whole square, which is equal to 2p plus 2 p square plus 2 plus 2p whole square. This is what we are getting in the previous answer. Exactly same. So in both ways you will get the same answer. Either you can take this as ft and then multiply the function by t and use the rule of tft, or you can take t into sine t as ft and then apply the rule of first shifting property. Okay, I hope the method is quite understood to you, and This is the lecture number 8. If you like my lecture, press the like button, share my lecture, and subscribe my channel also if you had not subscribed it yet. Thank you very much.